Good morning students. Welcome to science class. Today we are going to see third term first lesson light part 2. Students, it's time to revise our previous session portion. So listen carefully students. In last class we have seen that light is a type of energy that helps us to see all the things around us. Light is a type of energy that helps us to see all the things around us. Light is the only source of energy for plants. Light is the only source of energy for plants. Because plants produce food using the energy from sunlight, carbon dioxide and water by the process called as photosynthesis. So light is the only source of energy for plants. Next, we have studied about sources of light. Objects which are able to emit light are known as light sources. Objects which are able to emit light are known as light sources. There are two types of light sources, natural and artificial light sources. Sources which emit light naturally is known as natural source of light. Example, sun. Artificial light sources are man-made. Example, candle. Artificial light sources are man-made. Example, candle. Some living organisms have the ability to produce light named by bioluminescence. It is the effect of certain chemical reactions occurring in the organism. Once again I repeat, some living organisms have the ability to produce light named by bioluminescence. It is the effect of certain chemical reactions occurring in the organism. Example, fireflies. Next one, artificial light. Artificial light sources are man-made. They include candles, lamps and matches. Students, how does the moon shine? Is the moon a luminous object? We'll see. The moon provides light as well, but it cannot produce light by its own. The light emitted by the moon is the light of the sun reflected towards the earth. The light emitted by the moon is the light of the sun reflected towards the earth. When we see the moon, we see only the moon's lighted part. Thus, half of the moon is always facing the sun and receiving light from it. Hence, we receive light from the moon. Once again, I repeat, the moon provides light as well, but it cannot produce light by its own. The light emitted by the moon is the light of the sun reflected towards the earth. When we see the moon, we see only the moon's lighted part. Thus, half of the moon is always facing the sun and receiving light from it. Hence, we receive light from the moon. The different light sources that are able to produce light artificially classified into incandescent sources and gas discharge sources. What is incandescent sources? When certain objects are heated to a high temperature, they begin to emit light. The glowing of hot iron rod is a kind of incandescent light. Once again I repeat, when certain objects are heated to a high temperature, they begin to emit light. The glowing of hot iron rod is a kind of incandescent light. Example, bulb and candle. Second one, gas discharge sources. Passing electricity through certain gases at a very low pressure can produce light. Passing electricity through certain gases at a very low pressure can produce light. Example, sodium lamp and a neon lamp. Do you know, students? We often use a kind of gas discharge lamp that uses fluorescence to produce visible light. The electric current in the gas excites mercury vapor, which produces short-wave ultraviolet light that then causes a phosphor coating on the inside of the lamp to glow in visible light. Once again I repeat, we often use a kind of gas discharge lamp that uses fluorescence to produce visible light. The electric current in the gas excites mercury vapor, which produces short-wave ultraviolet light that then causes a phosphor coating on the inside of the lamp to glow in visible light. In last class, we have studied about properties of light. What are the properties? Light has some fundamental properties as mentioned below. First one, rectilinear propagation of light. That is, light traveling in a straight line in a medium. Second one, reflection of light. Third one, speed of light. Fourth one, interaction of light with matter. What are the interactions? Types of material according to permeability. What is permeability? Permeability means able to penetrate. Then formation of shadows. Next, plane mirror and images. The next property, formation of spectrum. Then we have seen the path of light. How does light travel? Light travels in straight lines. How do we know light travels in straight line? Now try looking through a bent hose. The light from the candle cannot reach your eyes. This shows that light does not bend but travels in straight lines. Students, light penetration through trees. See the picture. Light penetration through trees. Light travels through the holes in cement grill. This is picture of laser beam. Then we have studied about pinhole camera. Pinhole camera is a simple device which helps us understand the rectilinear propagation of light. That is, light travels in a straight line. A pinhole camera is a simple camera without a lens and with a single small pinhole. Effectively, it is a light-proof box with a small hole on one side and a translucent screen on the opposite side. Example, wax paper. Light reflecting from an object passes through the single point and gets projected as an inverted image on the screen. This is inverted image. Let's see the working model of pinhole camera. As light travels in a straight line, light reflecting from X strikes the box at X dash. This is X strikes the box at X dash. And light from Y strikes at Y dash. This is Y strikes at Y dash. Hence, light from all other points between X and Y on passing through the pinhole strikes at points in between X dash and Y dash. And an inverted image is seen on the screen. So, size of the image depends on distance of the screen from the pinhole. Distance of the screen from the pinhole. And then distance of the object in front of the pinhole. Distance of the object in front of the pinhole. Do you know, students? Before the advancement of camera, pinhole camera was used to photograph movement of the sun over a long period of time. This type of photography is known as solography and also be used for observing and recording solar eclipses. And it was also used to take photograph of stationary objects. Okay students, let's start today's session. Today we are going to learn about reflection, laws of reflection, types of reflection and beam of light and its types. So, above these topics covered into book page number 6 to 10. Students, make a note of important points. If you are having any doubt, note the question in notebook and it will be clarified on the day of reopening. Now, we are going to study about reflection. Water body reflects the scenery around it. Water body reflects the scenery around it. A mirror reflects our face. A mirror reflects our face. If you are passing the light to the mirror, reflection obtained in the another body. If you are passing the light to the mirror, the reflection obtained in the another body. The light fall on the surface is called incident ray. This is incident ray. This is incident ray. Light reflected is called reflected ray. This is reflected ray. This is reflected ray. Number of incident rays fall on the surface means will get various angles of reflected rays. The number 1 and number 2 rays are incident rays. 3rd and 4 are reflected rays. If 30 degree incident ray will reflect 30 degree reflected ray. The angle of reflection is 30 degree. Like that 60 degree incident ray will reflect 60 degree reflected ray. So this is the incident ray, this is reflected ray. Between the angle is angle of incidence. Now we will learn about terms used to describe regular reflection. What are the terms used in regular reflection? Incident ray, reflected ray, angle of incidence, point of incidence, plane mirror and normal at the point of incidence. We'll see one by one. First one, incident ray. What is incident ray? The ray of light that falls on the surface of the reflection materials. See the picture. Here PO is incident ray. O is a point, P is a ray, fall on the surface. This PO is a incident ray. Once again I repeat, the ray of light that falls on the surface of the reflection materials. In figure, PO is the incident ray. Second one, reflected ray. The ray of light that comes from the point when the incident ray falls on the reflection material. In the figure, OQ is the reflected ray. See the picture students. This is a point. This is a reflected ray. So OQ is the reflected ray. Next one, point of incidence. The point of which or incident ray strikes the reflecting surface is the point of incidence. In the figure, O point of incidence. Once again I repeat, the point of which or incident ray strikes the reflecting surface is the point of incidence. In the figure, O point of incidence. This is point of incident. O is the point of incidence. In this point, P is the incident ray, Q is the reflected ray. Next one, normal. The perpendicular line drawn from the point of incidence to the plane of reflecting surface is called normal. See the picture. This is a perpendicular line. The red line is a perpendicular line drawn from the point of incidence to the plane of reflecting surface is called normal. ON is the normal. Next one, angle of incidence. What is angle of incidence? The angle formed between the incident ray PO and the normal ON is angle of incidence. It is denoted by small I. So the angle formed between the incident ray PO and the normal ON is called angle of incidence. Next one, angle of reflection. The angle formed between the reflected ray OQ and the normal ON is angle of reflection. It is denoted by small r. See the picture. Reflected ray OQ and a normal ON. Between the angle is called angle of reflection. Now we are going to study about laws of reflection. First law of reflection states that the incident ray, reflected ray and the normal all lie in the same plane. Yes, see the picture. This is reflected ray. This is reflected ray. This is incident ray. This is normal. These three are lie in the same plane. Second law of reflection states that the angle of incidence I is equal to the angle of reflection. See, this is the relation. Angle of incidence is equal to angle of reflection. So once again I repeat. First law of reflection states that the incident ray, reflected ray and the normal all lie in the same plane. Second law of reflection states that the angle of incidence small I is equal to the angle of reflection small r. Let's see the example. In the figure, the incident ray makes 27 degree with the normal. Then find the angle of reflection. See the picture, students. This is incident ray. Incident ray and normal between the angle of incidence is 27 degree. So according to the law of reflection, the angle of reflection is equal to angle of incidence. So answer is 27 degree. Angle of reflection is 27 degree. Let's see the second example. A light ray strikes a reflective plane surface at an angle of 43 degree with the plane surface. First question, find the angle of incidence. Second question, find the angle of reflection. Third question, find the angle between the incident and the reflected ray. Fourth question, find the angle between the reflected ray and the plane surface. Let's see the answer. First, draw a diagram like this. So, this is a plane surface. There is an angle with the plane surface is 43 degree. So, plane surface and between the incident ray is 43 degree. So, what is the angle of incidence? So, normal is 90 degree. That is perpendicular line between the plane surface. So, angle of incidence I is equal to 90 degree minus 43 degree is equal to 47 degree. So, angle of incidence is 47 degree. Second one, find the angle of reflection. So, due to the laws of reflection, angle of incidence is equal to angle of reflection. So small I is equal to small r. So angle of reflection is 47 degree. Third question, find the angle between the incident and the reflected ray. So incident ray angle is 47 degree, reflected ray angle is 47 degree. So between the incident ray and the reflected ray angle is 94 degree. We have to add the two angles. Then fourth question, find the angle between the reflected ray and the plane surface. We want to find the x. This is a reflected ray and this is a plane surface. So we know that the angle between the normal and reflected ray is 47 degree. Want to find the x. So perpendicular line, that is 90 degree minus r, that is reflected angle. 90 minus 47 is equal to 43 degree. So angle between the incident ray and plane surface is equal to angle between the reflected ray and the plane surface. Both are 43 degree. Both are equal. Now we are going to study about periscope. How to make a periscope. Students, take an empty incense or agarbatti box, 2 mirror strips, scale, pencil, blade and glue. Draw square shapes on both ends of the box. Draw the diagonals to the squares. Slit the diagonals with a blade exactly as the length of the diagonal. Students, please note, the slit should be equal to the length of the diagonal. Fix the metal strips firmly to the box with the glue. We can also use a few drops of molten wax from a burning candle or Fevicol. Cut 2 windows on the narrow side of the box on either side near the reflecting surface of the mirror strips. Look from one of the windows of the periscope. Observe the things visible in the mirror. Yes, periscope uses the laws of reflection. Now we will study about types of reflection. The laws of reflection holds good for all surfaces irrespective of the shape. The laws of reflection holds good for all surfaces irrespective of the shape. Vertical surfaces, angled surfaces and even over the curved surfaces, the laws of reflection holds good. So a set of parallel rays striking the surface will be reflected at an angle, but the rays themselves will still remain parallel to each other. Rays themselves will still remain parallel to each other. Let's see the types of reflection. Depending upon the surface, reflection is classified into two types, regular reflection and diffuse reflection. Regular reflection or specular reflection occurs when parallel light rays strike a smooth surface and reflect in the same direction. Once again I repeat, regular reflection or specular reflection occurs when parallel light rays strike a smooth surface and reflect in the same direction. Second one, diffuse reflection. Diffuse reflection occurs when light rays reflect off a rough surface and are scattered in different directions. Scattered in different directions. See the picture, students. This is diffuse reflection. Let's see the examples of regular reflection and diffuse reflection. This is smooth water surface. So the reflection is regular reflection. We'll get a clear image. See the second picture. This is wavy water surface, that is rough surface. So the reflection is diffuse reflection. In fact, during the day, our classroom is illuminated by sunlight. Walls and floors are exposed to diffused reflection. Walls and floors are exposed to diffused reflection. Suppose walls were smooth, mirror-like, then sunlight entering through the window will get bounced by the floor at an angle above towards the roof, and it will never get reflected to left or right. That is, left and right wall will remain dark. Left and right walls will remain dark. Once again, I repeat, listen carefully. In fact, during the day, our classroom is illuminated by sunlight. Walls and floors are exposed to diffused reflection. Suppose walls were smooth, mirror-like, then sunlight entering through the window will get bounced by the floor at an angle above towards the roof, and it will never get reflected to left or right. That is, left and right walls will remain dark. Now we are going to study about beam of light. What is beam of light? Light is not a single ray but a bundle of rays which are called as a beam of light. A light beam can be a bundle of parallel rays, convergent rays and divergent rays. What is parallel rays? Two rays that lie on the same line. See the picture. Two rays that lie on the same line is called parallel rays. What is convergent rays? Rays of light which proceeding from different points of an object tend toward a single point. What is divergent rays? When a light rays starting from a point diverge themselves or spread themselves, such a ray is called divergent ray. See the picture. This is divergent rays. Let us look at the light coming from the sun. The rays of sunlight are parallel. Often, the headlight of car gives parallel rays. However, look at the rays of light coming out of a candle. Light rays go in all directions from the candle fire. These rays are divergent. Light rays from a flashlight is also divergent. Rays. Using lenses, we can converge light rays. Using a lens, you can focus sunlight at a point. That's what we are making the light rays to converge. Now we are going to study about speed of light. When lighting a bulb in a dark room, light spreads the whole room quickly. This is because the light travels very fast. Light travels 3 lakh kilometers per second in air or vacuum. This is very important point. Listen students. Light travels 3 lakh kilometers per second in air or vacuum. Once again I repeat. When lighting a bulb in a dark room, light spreads the whole room quickly. This is because the light travels very fast. Light travels 3 lakh kilometers per second in air or vacuum. Now we are going to study about interaction of light with matter. There are 3 different types of materials that light will or will not pass through. What are they? Transparent materials, translucent materials and opaque materials. Once again I repeat, there are three different types of materials that light will or will not pass through. What are the three different materials? Transparent materials, translucent materials and opaque materials. We'll see one by one. First one, transparent materials. Objects that allow light to pass through them are called transparent materials or transparent objects. Objects that allow light to pass through them are called transparent objects. Let's see the examples of transparent objects. The windows on a school bus, clear empty glass, clear window pane, the lenses of some eyeglasses, clear plastic wrap, the glass on a clock, a hand lens, colored glass. These are the materials which transparent the objects. Second one, opaque object. Objects that do not allow any light to pass through them are called opaque objects. See the picture, students. Objects that do not allow any light to pass through them are called opaque objects. So wood is a opaque object. Let's see the examples of opaque objects. Heavyweight paper, cardboard, aluminium foil, mirror, bricks, buildings, your eyelids and hands, solid wood door. These are the examples of opaque objects. Third one, translucent object. What is translucent object? Objects that are partially transparent and partially opaque are called translucent objects. They allow light to pass through them in a scattered or diffused manner. Once again I repeat, students. Objects that are partially transparent and partially opaque are called translucent objects. They allow light to pass through them in a scattered or diffused manner. So frosted glass is a translucent object. Let's see the examples of translucent objects. Thin tissue paper, waxed paper, tinted car windows, frosted glass and clouds are the examples of translucent objects. So students, transparent objects, all light passes through them. Translucent objects, some light passes through. Opaque objects, no light passes through. Okay students, I hope you are all understood about what is reflection, types of reflection, laws of reflection and beam of light and its types. Now let's see some textbook pages related to today's topics. Page number 6 explains about what is reflection and important terms used in reflection. What is reflection? Light propagates through different materials. What are the important terms? Incident ray, reflected ray, point of incidence and normal. These are the important terms used in reflection of light. Page number 7 explains about laws of reflection. What is the laws of reflection? First law, the angle of incidence is always equal to the angle of reflection. Second law, the incident ray, the reflected ray and the normal at the point of incidence lie on the same plane. Page number 8 explains about types of reflection. What are the two types? Diffuse reflection and specular reflection. Page number 9 explains about what is beam light and types of beam light. What is beam light? Bundle of rays which are called as a beam light. Generally light is not a single ray but a bundle of rays which are called as a beam of light. A light beam can be a bundle of parallel rays convergent rays or divergent rays. Depending upon permeability, materials can be classified into three categories. First one transparent materials, second one translucent material, third one opaque material. What is transparent material? Materials that allow light to pass through completely are known as transparent material. Example, eyeglasses, clear drinking glass, clear water, face glasses used in buses. Second one, translucent material. Objects that allow light to pass through partially are called translucent material. Page number 10 explains about opaque material. Materials that are not able to allow light to pass through are called opaque material. Example, wall, thick cardboard, stone, etc. Okay students, I hope you are all clear with today's session. It's time for evaluation. Be ready students. Answer the following questions. First question, what is a reflection of light? Second question, with the help of a diagram, state the laws of reflection. Third question, what is plane mirror? Fourth question, define transparent materials, give example. Fifth question, what is convergent rays? Okay students, first lesson light part 3 is to be continued in next session. Thank you.